All right, good afternoon, good morning, wherever you may be today. My name is Andrew Sartorelli. I'm one of the product managers here at nTopology. It's my privilege today to talk to you a bit about what's new in nTop platform. So what have we done over the past few months, and a little bit about where we're going next with our product here. So today, as I said, we're going to talk a bit about nTop platform, an overview of what we have today. And we'll dive into three key topics. One is going to be our new topology optimization workflow. We've added quite a bit of things there since we rolled this out middle of last year. I think there's a few noteworthy additions that are coming very soon, and that'll be of interest to a lot of folks. Next is some new possibilities for interoperability with a variety of different tools. We'll touch on some of the user experience enhancements. So I think these are a lot of things that make the day-to-day use of the software a lot easier, a lot more enjoyable for folks. And then at the very end, I'll give a quick sneak peek of some of the new latticing technology that we have coming out later this year. So for those of you that may not be familiar with nTop platform really is a computational modeling tool that combines design, simulation, manufacturing data into a single environment. So we're able to work with different data types to really generate designs that you aren't able to generate with traditional tools, and capture the knowledge of the process to create that design to allow you to share that information with colleagues, customers, and other folks, even yourself, to go back at a later date in time and actually understand your thought process to create a component. And the reason we've created nTop platform simply is legacy engineering tools weren't built to solve the problems of today. When we think about BREP-based modeling tools, they were designed with subtractive manufacturing in mind. They weren't designed to think about additive manufacturing. And so as we look to additive manufacturing and other new advanced manufacturing methods, we need new tools to help solve those problems. And so we do that through a technique called implicit modeling. And so we represent geometry in a slightly different manner than traditional engineering tools. So on the left, you can see the approach that a traditional tool may take to discretize an object and come up with this boundary patch representation. On the right, you see the representation that we use in nTop platform, which is this implicit representation. So representing geometry as a single equation or a single function, and that allows us to do some very powerful things. So if you think about one of the most common operations in solid modeling, it's combining two parts together, unioning two parts. And what you see on the left is the math that's required to perform that operation with BREP geometry. So it's quite complicated, it's really in-depth, and it's quite prone to having problems. And what you see on the right is how we do this in nTop platform. For a simple minimization function, we can combine two objects, and we combine them exactly and without problem. And so this ability to work with equations or functional-based representations of geometry gives us the ability to really create unbreakable geometry. So we can have these incredibly complex parts. Here we see a part infilled with a gyroid structure, and that thickness varies throughout it. Something you can't do with a traditional tool, but because we're representing everything on this mathematical functional basis, it's quite easy for us to do. We don't worry about any of our modeling operations failing. And at the core of this modeling platform is the ability to take in and use data from a variety of sources. So today, more than ever, we're seeing data coming not only from simulation or experimental, but you may have knowledge stored in Excel sheets or other forms of data that you want to bring in, combine together to come up with your designs. And now these designs traditionally are not thought through well enough with traditional tools because you're not combining all of that information that you have. But with nTop platform, we're able to pull in data from all of those different sources and come up with these truly optimum designs. And thanks to implicit modeling, those operations that don't fail, we end up with some incredible designs that we'll see in a bit. So first off, on enhancements that I want to talk about today, it's really what we've done for topology optimization. And so at a high level, we've added quite a bit, but I think one of the most interesting things that I was hearing quite a lot from customers is the need to go back to traditional CAD tools or bringing data back into a PLM environment. And so in a bit, I'll show you some of the work we've done there to allow for exporting out our geometry in step format, so you can bring it back to these traditional tools, perform some additional modeling operations, merge it back with assemblies and things like that. But first, I really want to highlight some of the features that have gone into this topology optimization workflow to allow you to come up with these designs. So the first one we have here is the addition of bearing loads. So for those of you working in turbo machinery, aerospace, automotive, you know how important this type of loading condition is. And so we've taken a sinusoidal approach to solving this, this loading condition. And you'll find that was released in nTop platform 2.8. Next up, we have the addition of point restraints. So this was added in nTop platform 2.7, which was only a couple of weeks ago if we think about it. And this one allows you to add in some additional capabilities. If you want to have, say, a joint that is able to rotate somewhat freely about a given axis, we can see the difference in performance of that part here by having the accurate boundary conditions available. Next up, we have objectives and constraint charts. So this is allowing you to see, for topology optimization specifically, how your objective is approaching the minimization over the course of multiple iterations. So we can go back after we've run the analysis, look at the total objective, or look at any of the individual constraints that we may have specified. And helping to ensure that you get results in a faster amount of time, you're able to iterate through more design possibilities. We've actually introduced multi-threading for topology optimization workflow. And so we're seeing reduction, the order of 45%, depending on the size of the model, as well as the complexity of the loading cases. And so now, instead of taking advantage of one core, we're essentially taking advantage of just about as many cores as you have available on your machine, and then leaving one free for the operating system to use for background operations. And so these improvements to the topology optimization workflow are not only for top-op, but you can see some of these speed improvements as well for simulation. And so that was released in nTop platform 2.5, which was approximately 6 weeks ago. Next up, so we rolled out topology optimization, as I said, end of last year. And so since then, we've actually added a couple of constraints. So thinking back to that chart where we can see how our constraints are performing over the course of our iterations. Well, the new ones that we've added are stress constraint, as well as displacement response constraint. So this will allow you to specify a maximum stress that you want to have within your analysis, and then that'll be constraining the actual optimization process. And so this was released in nTop platform 2.2, which was approximately January, February of this past year. All right, and I think the one that's going to excite the most folks for topology optimization is actually the ability to export out step files. So we've heard, as I said, from a lot of folks that they want the ability to use nTop platform to create these incredibly complex designs that you simply can't do anywhere else. Use our smoothing algorithms and variable shelling to generate some complex parts. And then they need to bring that back in with the rest of their models for an assembly. And so what we'll be rolling out in the next few weeks is actually the ability to take that model from nTop and bring it into your solid modeling tool of choice. So in this case, we can see we've done the topology optimization inside nTop platform, and then we're able to export out a step file and bring that step file into NX. Now, that step file that we're exporting here, right, it's starting with something like what we see on the left inside nTop platform with a NURBS-based mesh, and then we're able to do some patch consolidation to simplify that model a bit. And then we can bring that right back into traditional CAD tool, perform standard geometric modeling operations, whether you want to do booleans, blends, shelling, all of that sort of thing is possible with these models because we're generating healthy BREP CAD geometry. So you could go back and merge that with your assembly and then continue down the process, maybe to manufacturing, or just add it back into your PLM system. So I'm just going to pause here for a second because there are a few questions I see here on topology optimization. Okay, and let's see, the first one here is, are these constraints available with a minimum mass type of objective? So we have a compliance minimization objective as well as a mass minimization objective in top platform. So yes, you can use those as secondary constraints to the optimization process. Are you planning to add hyperelastic simulations for flexible materials? Great question. So we would have the ability to add in hyperelastic materials. We haven't done that yet because I think a lot of folks that are doing these really nonlinear materials, they're running those simulations in tools like Abacus or LS-DYNA. And so what we do facilitate is we facilitate people sending their simulation models directly from nTop platform into their simulation tool of choice. All right, next one here. Will the step file export handle sharp edges better than step file exports? I think maybe that was STL file export. Yep. Yeah, so there are some methods for preserving sharp edges with this step file export. And we can talk a bit more about that once we fully add in that functionality. Can we apply load which is offset from the actual body for static analysis? Yes, we do have remote loading conditions available as well. All right, so I'll jump back over and let's talk a bit about data exchange. So we've added this new capability within nTop platform to export out 3MF files. Now, for those of you that are familiar with mesh-based formats, we know that STL is kind of the format of choice for a lot of folks, and particularly in additive manufacturing, but that format has a lot of problems. And so we've decided to adopt the 3MF file format standard. And so with that, for a part like you can see here, this topology optimized bracket, the mesh was not too bad for an STL. It's 6.5 megabytes, but with a 3MF file, you're able to drop that down by about 65% and get it to about 2.3 megabyte. So this option is available in the just released nTop platform 2.8. And this will work on any triangle-based mesh. So it's not able to support quad-based meshes, and this is just a limitation of the 3MF format. The next one that I'm pretty excited about is for those of you working with really complex lattice structures, you know that the problems of trying to mesh those geometries, you end up with a file that's huge, that's massive. And so we've decided also to support the 3MF format with the Lattice extension, and this will be coming in the next release, nTop platform 2.9. And what this allows you to do is to store that graph lattice structure in this 3MF file format. And of course, if we can store a mesh and we can store a lattice, well, we can store both a mesh and a lattice together. And so what we'll be doing is supporting the 3MF container format as well. This will be coming in nTop platform 2.10. So essentially you could do, like we've seen here with this hip cup, you generate your Voronoi, your trabecular lattice structure, you store that as the graph, and then you store the mesh as a separate entity, and you can send that part off to a build prep tool of choice and fully capture all of that data without trying to lug around a 300 megabyte STL file. All right, so there's a question like, where can I actually use a 3MF file? So there's a lot of consortium members, and we'll talk a bit about who those are, but in this case, we were able to export out this lattice structure that we generated into our build prep tool of choice. In this case, was Materialize Magics, which also supports the 3MF lattice extension. So if you want to, design these complex parts and you're using a build prep tool, you have that ability to easily transfer the data between the two. Now, another one that is kind of one of my personal favorites, if you're creating a lot of PowerPoint presentations, you can actually embed a 3MF file within a PowerPoint or Word doc or Excel file. And this is because Microsoft is also a 3MF consortium member. And just to give a kind of rundown of who those members of the consortium are, you can see it's a lot of players in the industry. 3MF is not a format that we have invented on our own. A lot of the players from the software side, the machine side, as well as other consumers of this are founding members of this consortium. And you can see the link below at the bottom if you want to take a look and understand what software tools, what machines, and what other tools are supporting this format. Take a look there. All right, so there is one question on the topic of data transfer, and it's, are you able to directly export lattices into slice format without having to mesh? Yes, so we have the ability to directly slice graph lattice structures and generate points that correspond to the beam. If you're interested in that, we'd be glad to give you a demo afterwards and go further into details on how you can use that workflow to speed up the manufacturing process without needing necessarily to go to a dedicated build prep tool. Okay, next on the list is user experience enhancements. And I think these are a lot of ones that really help folks in the day-to-day. So for those of you using nTop platform, it's the most advanced modeling tool out there, and you can generate things that are simply not possible in other places. And we're trying to find ways to make that easier for everyone to use. So actually, I'm going to jump into a bit of a live demo now. And let's take a look at a few of those improvements. So the first one that I want to bring up is the commenting. So to me, commenting is one of the most powerful things that we have in nTop platform, because it allows you to store the knowledge of how the process was created, what you're thinking about during the process. And so at the end of the day, you're tasked with creating a part or a component, but you're really tasked with capturing that knowledge to create that component, because we've all had those situations where you get this one-off part, and then 6 months down the road, turns out it's not a one-off part. You have to actually figure out what you had done before and maybe make some modifications. And it tends to be quite tricky if you haven't documented your process. And I think comments really are one of these ways to help easily document the process. And so we've kind of called them out a bit more with a nice little background and allowed for multiple lines of comments here. And so if we look at this topology optimized bracket we have here, we've actually done something nice with our section cut capability. So previously section cut would only work on a single component, and now we can just slice through all of the parts within our viewport quite readily, quite easily, regardless of if they're implicit models, if they're CAD parts, if they're mesh parts, we can slice through all of those objects with ease. Another nice one here is if we go ahead and take a look at one of our fields. Let me just isolate. Oops. If we go ahead and take a look at one of our fields here, let's see. Working on multiple monitors is a bit of a challenge. All right, let's take a look at some of the other enhancements while I wait for that to work. So one of the things I was really excited about was the ability to start filtering out mesh entities. So if we think about what happens when we generate a mesh for infilling a part with a lattice, right? Let's take a look at that. So I'm going to generate a volume lattice, and I'm going to infill my cube here, and maybe I just go body center cubic. And let's go 3 by 3 by 3. All right, and let's thicken this up. So as we generate meshes for this geometry, whether it's an STL file or if it's a 3MF file, tends to be kind of small noise shells added to during the discretization process. And so one of the things we've added is these new mesh utility blocks. So if I go up and I'm just going to say merge, we have this ability for merge mesh, filter mesh, and split mesh. So what these 3 blocks can be combined to do is actually to isolate those noise shells. So a split mesh will take in a single mesh entity and split out the individual shells that represent that geometry. The filter will allow you to specify a volume threshold. So say you want to remove all shells that are below 1 millimeter in volume. You can go ahead and filter that out, and then you can go ahead and merge all of those shells back together to allow you to, eliminate some of that noise in the process. It's going to cause problems during toolpath generation for additive manufacturing. So a couple of questions here actually about seeing that exporting lattice structure in slices. So you can actually go ahead and quickly run through that. So under manufacturing, we're going to have a slice lattice option here. And we can just go ahead. I'm going to specify maybe 0.1 millimeter, and we'll include the negative and isolate. And now you can see we've generated points for this entire graph lattice structure now, quite quickly, quite easily, allowing you to then send that off. You could export this as a CLI file or even CSV data and use that to directly manufacture these complex lattice structures without needing necessarily to go to mesh or even to a solid representation of that geometry. Okay. So while I've got this one open, I'm actually going to go ahead and take a look at the field that represents this geometry. So for those of you that aren't familiar with the implicit modeling, we're representing everything as this sign distance field. And so we can measure the distance from our object everywhere in space. And one of the things we've added for visualizing fields and accessing them is this ability to probe values. So I can go ahead and just use the probe values, and now we're able to mouse over our contour here, and we can see the values representing our geometry. Now, in this case, it's a distance field, but you could use this on any field that you've created in nTop through the field viewer. If I just go back here, one of my favorite additions to the software actually is what you see at the bottom of the screen, which is the ruler. So I'm able to drag this ruler now and say I want to get a rough idea how thick something is. I can just go in and see, all right, I've got an approximate value now to use to understand, is the design process going the way I had expected? Is this value propagating through correctly? All right. I think one of the last ones that I actually missed over because it just seems so intuitive now, and you may not have noticed it, is the hiding automatically of nested blocks. So we've added a new setting, and let's just pull it over. Oh. And the setting allows you to essentially turn on or turn off this ability to auto hide nested blocks. So say I go ahead and drag my lattice out, and I turn on the visibility. As soon as I drag that in, you see it should automatically turn off the interior blocks. All right, so it looks like we have about 5 minutes left. So I want to do just one quick sneak peek of what's coming next in nTop platform. And so, I think a lot of people know us for latticing tools, and I think we're pretty far out there in terms of what our capabilities are today, but we're going to push that a bit further because we're seeing that a lot of folks want to have customized unit cells, right? They want to design their own lattice structures. And we see that, and we want to take that to the next level. So not only are we going to allow people to create customized lattice structures, we're going to allow them to create fully parameterized lattice structures. And what does that mean? So if I take a look here, I have a simple BCC lattice structure that we're viewing from the top down. And I parameterized the structure in such a way that I can start moving the center point. So if I take a look here at this next one, the X, we'll actually see that the center point is moving in different directions. And that's because we're driving this based off a field that we've specified. So that field today is just a distance field, but if you think about it, it really could be any field. It could be the results of an impact analysis. It could be thermal results. It could be CFD results that you want to use to start morphing the structure to architect a response that you can't get from simply specifying a single unit cell. Now, we can specify this to morph in the X direction, the Y direction, or even we can start combining this together, morphing the structure in X and Y, because that's how my parameterization was defined, and adding thickness variably throughout that structure as well. Okay, and one of the last two things I want to talk about here is a request that we've gotten a lot from a lot of folks, and this is space mouse support. So I'm really happy to say that coming in nTop platform 2.9, which should be out fairly soon, we will be supporting space mouse. And to make sure that you always get those updates, we have added this ability now to easily see when updates are available. This green download link in the upper right-hand corner of the nTop platform. Be sure to download that new version as soon as it comes out. Okay, I think now we'll pop over and take a look at a few of the questions. All right. Does nTop platform count the number of triangles, faces, and vertices in lattice structures? For faces and vertices, we do. That's one of the properties available for any graph lattice structure that you may create. Can you support SLC file generation in the future release? We can certainly take a look at that. We're always looking to expand the number of file formats that we support for additive manufacturing. What type of information can be exported from the parameterized lattice structures? So that's a really good question. I think one of the really interesting things that we can do with these parameterized lattice structures is that actually start to quantify the behavior. So we could do either physical testing, right? That's data that we can read into nTop, or we could do homogenization of these individual unit cells and start to understand the behavior of the spectrum of the material. And understanding that spectrum of material will really allow us to start architecting responses, creating an architected material that you've created, right? This is not something that we're gonna design for you. You have full control over that process to design a material the way you want to design in the performance, the behavior that you're looking for. All right, can the lattice structures also be exported in step format for further native CAD editing? Good question. So I would recommend exporting out lattice structures in 3MF file format rather than a step file format, right? If we think about traditional BREP-based modeling tools, there's a reason that you typically can't create BREP lattices. I've heard from a lot of folks, they've tried to create gyroid structures and things like this, and they've spent weeks and months trying to do that. It's all about using the best tool for the application. And so in this case, I wouldn't recommend exporting out a really complex lattice structure as a step, although you could do that. recommend going out with something like the 3MF because it's going to be easier to then go ahead and manufacture that data afterwards. And can we do multi-material topology optimization for lattice structures? For instance, if two materials are defined simultaneously to optimize the geometry. So we don't have the ability to do topology optimization right now with multiple materials. It's an area I'm actually really interested in. But you could actually set up this geometry to have multiple materials in it. If we think about implicit geometry, and one of the benefits of this modeling approach is that things like Booleans, whether it's subtract or union, are really easy. So you could actually subtract in or union in with different objects to represent different materials throughout the structure, and then directly slice that. So you're not trying to mesh with the interface mesh or anything like there. It's just directly slice that geometry and send it to your printer. Is there any support for voxel-based data structures? Yes, so we do support importing with the OpenVDB format voxel data. And that's one of the geometry types that exists within nTop platform. So you could convert that either to a mesh, or you could take that voxel data and directly convert it to an implicit representation. All right, it looks like we're a few minutes over schedule here. So I really appreciate everyone taking the time to join us today. Let me share a little bit about what's new with nTop platform, what's coming down the pipeline, and tune in next month for another edition of What's New in nTop platform.